Welcome to chemistry classes by Vijay Kumar Sethi. We were discussing unit first of class 11th chemistry, some basic concepts of chemistry. And in this video, we are going to discuss about significance of a balanced chemical equation, limiting reagent, stoichiometry, and stoichiometric calculations. First, come to the balanced chemical equation. According to the law of conservation of mass, a balanced chemical equation has the same number of atoms of each element on both sides of the equation. You can see this reaction. CH4 methane reacts with the oxygen to give CO2 and water. In this case, methane and dioxygen, these are called reactants, and carbon dioxide and water are called products. All the reactants and the products are in gases in the above reaction, and this has been indicated by the letter G in the brackets next to its formula. You can see this G represent that these reactants and products are in the gaseous state. Similarly, in case of solids and liquids, we will write S and L, and if aqueous solution is there, then we will write AQ. The coefficients of 2 for O2 and H2O. Now, what is the meaning of this coefficient? This is 2 for O2 and this 2 for H2O. These coefficients are known as stoichiometric coefficients. Here, and similarly, the stoichiometric coefficients of CH4 and CO2 is 1, and generally it is not written here. This is its stoichiometric coefficient is 1 and its stoichiometric coefficient is also 1. Clear? Now, what information we can obtain from a balanced chemical equation? That is, what is the significance or implications of a balanced chemical equation? We will take the one example, like hydrogen reacts with oxygen to give water, and this is balanced chemical equation. 2H2 plus O2 gives 2H2. Now, what information we can get? We can find out the names of reactants and products. From this example, we can say hydrogen and oxygen reacts to give water. Composition of each reactant and product can also be find out. You can see H2 and O2 are composed of 2 atoms of hydrogen and oxygen respectively, and water is composed of 2 atoms of hydrogen and 1 atom of oxygen. Relative masses of reactants and products. Now, from this equation we can say 4 gram of H2 reacts with 32 gram O2 to produce 36 gram of water. If we know the molar mass of these reactants and products, we can find out these masses. The same way, relative number of atoms or molecules, with the help of stoichiometric coefficient, we can find out. That is, 2 molecules of H2, this 2, okay, 2 molecules of H2 react with 1 molecule of oxygen to give 2 molecules of water. This is 2, and in this case nothing is written, that's why we can say its stoichiometric coefficient is 1. Relative number of moles of reactants and products can also be find out with this balanced chemical equation. 2 moles of H2 reacts with 1 mole of O2 to give 2 moles of water. Relative volumes of gaseous reactants and products. Okay. If this reaction is carried out at the standard condition, it is at STP. Now, what is this STP? Standard temperature and pressure. Clear? And in this condition, temperature is 0 degree Celsius and pressure is 1 bar. And at STP, the volume of 1 mole of gas is 22.7 liter. Is that clear? At STP, that is standard temperature and pressure. Temperature is 0 degree Celsius and pressure is 1 bar. The volume of 1 mole of gas is 22.7 liter. In this equation, we can say 2 mole of hydrogen is there. That's why 2 into 22.7, that is 45.4 liter of hydrogen reacts with 22.7 liter of oxygen. Okay, if we can find out only the volume of gaseous substances. And these mass, moles and number of molecules are related to each other. If we know the mass, we can convert into the moles, and if we know the moles, we can convert into the number of molecules. Okay, and if we know the mass and volume, we can find out the density. Stoichiometry. The word stoichiometry is derived from two Greek words, stoichion meaning element and metron meaning measure. Thus, stoichiometry deals with the calculation of masses, sometimes volumes also, of the reactants and products involved in a chemical reaction. Here, if there is a balanced chemical equation, we can find out the masses and volumes of the reactants and products. Next is limiting reagent. If one of the reactant is in more amount than the amount required by a balanced chemical reaction, the reactant which is present in the least amount gets consumed after some time, and after that further reaction does not take place, whatever be the amount of other reactant. Here, so we can say the reactant which gets consumed first limits the amount of product formed is called the limiting reagent. Simply we can say the reactant which present in the lesser amount which consume first and decide the amount of product formed. That's why that reactant is known as limiting reagent. See the one exercise question 1.23. In a reaction, this is given A plus B2 gives AB2. Now we can say in this case the stoichiometric coefficient of this A and B2 is 1, 1. Identify the limiting reagent, if any, in the following reaction mixtures. That is, if you are having 300 atoms of A and 200 molecules of B2. Actually, this A is in atomic form and this B is in its molecule form. That's why B2. Okay. Now again, there is a 1:1 ratio. If we compare the ratio of this 300 and 200, which is smaller, we can say this one is smaller. That's why we can say B2 is the limiting reagent. The same way, 2 mole of A and 3 mole of B2. Ratio is 2 and 3. Which is lesser? This is 2. That's why we can say limiting reagent is A. 100 atoms of A and 100 molecules of B2. Ratio is 1:1. That's why no one is there limiting reagent. 5 mole of A and 2.5 mole of B2. We can say this is lesser than the stoichiometric coefficient. That's why that is ratio. Lesser than the ratio of stoichiometric coefficient. That's why B2 is the limiting reagent. And in this case, 2.5 mole A and 5 mole B2. Again, we can say this is smaller. This is lesser amount. That's why A is the limiting reagent. I think this concept of limiting reagent is clear to all of you. Now we'll discuss some calculations based on the stoichiometry. That is stoichiometric calculations. Okay. These are the solved example of your textbook. Calculate the amount of water produced by the combustion of 16 gram of methane. Again, remember 16 gram of methane when burns. Then we have to write first what is the balanced chemical equation for this reaction. So you can write this is the formula of methane. When this burn means react with the oxygen. Again, each hydrocarbon when burns it produces carbon dioxide and water. We balance it. The stoichiometric coefficient of methane is 1, for oxygen is 2, this carbon dioxide is 4, 1 and water is 2. So we can say from this balanced chemical equation 1 mole of CH4 gas gives 2 mole of H2O. Is it clear? Now in the question 16 gram of methane is given. And as we know, molar mass of methane is 16 gram per mole. And that's why we can say 16 gram of methane is equal to 1 mole. And 1 mole of methane produce 2 mole of water. So hence we can say 16 gram of methane produce 2 mole of water. Okay. And this 2 mole of water can be converted to the mass. If we know the molar mass of water is 18 gram per mole. That's why when this number of moles is multiplied by molar mass, we will get the mass of water produced, that is 36 gram of water. See one more problem. How many moles of methane are required to produce 22 gram of carbon dioxide after combustion? Again, combustion of methane is taking place. That's why balanced equation is this CH4 plus 2O2 gives CO2 plus 2H2O. And again 1 mole of carbon dioxide is obtained from 1 mole of CH4. With the help of stoichiometric coefficient we can find out this. Molar mass of carbon dioxide If atomic mass is we know, we can find out this will be 44 gram per mole. But in the question, mass of carbon dioxide produced given, that is 22 gram. That's why this 22 gram of carbon dioxide will be converted into the number of moles. Number of moles of carbon dioxide is equal to mass in gram divided by molar mass in gram per mole. Put the value, we can find out 0.5 mole of carbon dioxide. Okay, now see, there is 1:1 ratio between carbon dioxide and methane. That's why we can say 0.5 mole carbon dioxide would be obtained from 0.5 mole CH4. Or in other terms, we can say 0.5 mole of CH4 would be required to produce 22 gram carbon dioxide. Clear, student? Now see, this is the one problem which is based on the limiting reagent. 50 kilogram of N2 and 10 kilogram of H2 are mixed to produce NH3. Calculate the amount of NH3 formed. Identify the limiting reagent in the production of NH3 in this situation and mass of NH3 produced. First of all, write the balanced chemical equation. N2 plus 3H2 gives 2NH3. Then in the question, mass of N2 is given in kilogram. First we'll convert into the gram. Okay, and in the same way, mass of hydrogen is also given in the kilogram. We will convert into the gram. Molar mass of N2 is 28. That's why first we'll find out the moles of N2 present in 50,000 gram. So this is mass in gram divided by molar mass of N2, and this will come this. This is the number of moles of N2. In the same way, we can find out the number of moles of H2. Is that clear? Now, according to this balanced chemical equation, 1 mole of N2 requires 3 mole of H2 for the reaction. That is, stoichiometric coefficient of nitrogen is 1 and for hydrogen is 3. 1:3 ratio. Okay. Now, hence, for 1785.7 mole of nitrogen, how many moles of hydrogen required? It's 3 times. Okay. That's why the moles of hydrogen required would be multiply this 1785.7 by 3, you will get this one. That is, number of moles of hydrogen should be 5,375.1 mole. But we have only 5,000 moles of hydrogen. That's why we can say dihydrogen is the limiting reagent. Clear? Now, amount of product is decided by hydrogen because this is the limiting reagent, and the moles of hydrogen available is 5,000 mole. So we can say when 3 mole of hydrogen gives 2 mole of NH3, then how many moles of NH3 will be produced by the 5,000 mole of H2? So simply unitary method is there. From 3 mole of hydrogen, we will get the 2 mole of NH3. That's why from 5,000 mole of H2, 2 mole of NH3 divided by 3 mole of H2 multiplied by 5,000 mole of H2 will get 3,333.3 mole of NH3. Okay, this is mole. Now this mole can be converted into the mass if you multiply it by molar mass of NH3, and molar mass of NH3 is 17, and we will get this in gram, and this gram can be converted into the kilogram. By rounding off, we will get this answer. Is it clear? Subscribe my channel to get the new video. Thank you.